rice, and Dr. Dan is going to make presentation of his work on rice. That's
Yes.
very good. Welcome, Vaisa. Good morning. Looks like Roy, Dr. R.K. Singh has some issue in connecting with audio, I think. But can you hear us?
Yes, sir. He has not joined with his audio, sir.
Huh?
His audio is off.
Angubal? He's having some problem with audio. He will log out again once and then he will join again.
Yes, sir.
Can you hear us or now? Still he has problem. Yeah, we can see you, sir. Can you hear us?
Burman, I think, Dr. Burman, you can put your sound on, no? At your level?
No, his audio, he has not joined with audio, madam. So I think he has joined from his phone. So he has to select audio and then call over internet.
So can we, maybe you can call him and give him the instruction?
Yeah, I have asked Gopal, he is connecting with him. I have asked Gopal, he is talking to him.
Okay.
shows audio connecting. But
Yes, sir. Now I think he has selected that call over internet.
No, he is connecting from not from mobile, from his desktop probably.
His audio has come, sir.
Yeah, looks like. He is muted, I think. Sir, unmute kar le. I think you can hear us now. Na unmute kar lijiye mic.
Unmute.
Yeah, now we can hear you. Thanks a lot. So there has been some trouble. in the
Technology is
beginning.
not good. Always, new technologies are always difficult for older people.
Fine, sir. But good that you are finally connected, and we will start with this program, sir, with your permission. And
Oh, sure.
I would like to welcome each one of you. And friends, it's a great pleasure to welcome Professor R.K. Singh, former Director of Research at NDUAT Kumarganj, Ayodhya, who is going to chair this Hooker Award lecture, which has been given this time to Dr. Sarath Kumar Pradhan, Principal Scientist in Genetics and Plant Breeding at ICR National Research Institute, Cuttack. My colleague, Dr. Rasmi Agrawal, Dean and Joint Director Education, Joint Directors of IRI, Project Director, Heads of the Divisions, Professors, faculty members, ladies and gentlemen, and students. We also have Professor R.M. Singh, former Head Genetics and Plant Breeding Department from Banaras Hindu University, with us. He has joined. I extend a warm welcome to each one of you on the 4th day of Convocation Week. We started this program on 7th, and 7th and 8th we had the presentation of students' medal, gold medal presentation for the significant research findings. And then we had a presentation 2 days by the professors of respective discipline, significant research finding of other students who could not be selected for the presentation of gold medal. And this is the first award lecture that we are going to have today. And this particular award, Hooker Award, has been initiated since 1972. And it was instituted by the Indian Agriculture Research Institute to recognize the outstanding contributions in any field of research in agriculture, animal husbandry, fisheries, leading to increase in food production. The award has been instituted on the basis of a legacy bequeathed to the institute by Mr. and Mrs. Richard Hooker of USA. And the Hooker Award, which is made in alternate years, carries a cash prize of rupees 15,000 and a citation. And this time we have this award lecture to chair with us. We have Professor R.K. Singh. I will tell briefly about Professor R.K. Singh. He did his graduation and post-graduation from Government Agriculture College, Kanpur. Brilliant scholar all through, has been topper of UP board in his time in intermediate. Did his PhD from Rostock University, Germany, and 2 postdoc from University of Hohenheim and University of Birmingham. And then joined directly as Associate Professor of Genetics in the College of Basic Sciences at Haryana Agriculture University, Hisar. And there he also served as professor and head of the department. And for a very brief period, he served at Banaras Hindu University as professor of genetics and plant breeding where I had opportunity to be his student for one semester. And what a wonderful teacher. After that, he left and joined as Director of Research at Narendra University of Agriculture and Technology, Kumarganj, Ayodhya. And while serving at the university, his initiative in terms of establishing international linkages with CG system was enormous, and initiating large number of programs. And then as IRI legend scientist, he worked for 10 years. And during this period, again, most of the universities in Eastern India, they were very well connected with IRI, number of programs, the consortium of upland rice ecosystem. Then participatory plant breeding program, he started in a big way. And large number of scientists were trained at IRI during his period from the agriculture universities. After his retirement from the active service, he is still very active, serves as the executive director of NEFOR, that is Nand Educational Foundation for Rural Development, helping farmers with technology and knowledge in Eastern India. He played pivotal role in popularization of Swarna Sub-1, a variety which has submergence tolerance in Eastern India. Dr. R.K. Singh is worldwide known for his work in biometrical genetics and quantitative genetics, and his book on biometrical methods in quantitative genetic analysis, co-authored with Chaudhary, Singh and Chaudhary. This was a landmark book. In fact, this was the book that laid the foundation of many of the quantitative genetics model, and the softwares developed using this book for a statistical analysis in ISRI at that point of time. In addition to that, Dr. Singh has a rare distinction of being a great literary person. साहित्य में इतनी रुचि है और जो लेखन है आपका वो सबको प्रभावित करता है। एक रचना इनकी आनुवंशिकी के प्रथम सोपान, जो हिंदी में मेंडल के नियमों की व्याख्या कविता के रूप में की गई है, और खासकर मैं अनुरोध करूंगा जेनेटिक्स के जितने विद्यार्थी हैं कम से कम सभी लोग पढ़ें, जेनेटिक्स के विशेष रूप से इसको पढ़ें। इसके अलावे एक किताब इनकी मेरी गुड़िया, जो कि हरियाणा साहित्य अकादमी के द्वारा पुरस्कृत किताब है, पोखर के पांव है बेवाई, एक कहानी कविता संग्रह है, और उसके साथ साथ कहानी संग्रह जिसमें इनके अपने खुद के संस्मरण और आत्मकथाएं हैं। ये सारी चीजें इनको एक अद्भुत व्यक्ति के रूप में समाज के सामने पेश करती हैं, सबसे अलग। मैं विशेष रूप से डॉक्टर R.K. सिंह का धन्यवाद देता हूं और स्वागत करता हूं कि उन्होंने हमारे इस अनुरोध को स्वीकार किया to chair this particular award function, which will be delivered by Dr. S.K. Pradhan. And Dr. Pradhan is an outstanding rice breeder, has developed more than 45 rice varieties. And if you look at his publication in last decade, at least more than 20 papers, all exceeding impact factor of 10 NAS impact factor, and outstanding contribution in molecular marker assisted breeding. He is fellow of National Academy of Agricultural Sciences. And we are pleased to have you, Dr. Pradhan, with us to deliver the Hooker Award lecture. And with that, I will request Professor R.K. Singh for a brief initial remarks at this point of time, and then we will hear his comment after the award lecture. Professor R.K. Singh.
Thank you, Dr. Ashok Singh. I was a little bit, not quite much of organized, because for almost a week my wife was admitted in the hospital, so I could not see the message about this meeting. And just in the morning, only about an hour or so, Dr. Ashok reminded me, and then I found that there is a meeting of this kind, and I'm so happy that a friend of mine, Dr. Sharad Pradhan, has been given this prestigious award. I have known him for several years, and I know that he is a very brilliant scientist. Every time that he publishes a paper, he informs me about that, sends me a copy, and I feel that we need this kind of young scientists who who bring out our agriculture to a greater height. And I'm thankful to Dr. Ashok Singh that he invited me to join this meeting. And I didn't know, but that now I know that I have to chair this meeting also. So without any delay, I think let us first have the lecture by Sir Pradhan and other formalities completed. And then maybe we can discuss if time permits in the end. Thank you, Dr. Ashok, once again.
Thank you, sir. Thank you, sir. Dr. Pradhan, over to you. You're sharing your presentation from there, right?
Yes, sir. Thank you, sir, very much. Very good morning to all, Honorable Chairman, Honorable Director, IRI, Honorable Associate Dean, Joint Director Research, heads of the division, professors, scientists, faculties, and attending students, and my friends. Actually, I profusely thank to IRI for selecting me for this award, and the selection committee. I'm extremely thankful to the whole team, particularly director, deans, and selection committee. So I feel very fortunate enough. My name is included in this prestigious award, Hooker's 26th Hooker's Award given by IRI. So I highly appreciate and give thanks to whole IRI authority. So now I will be presenting my talk. So please give time so that I am sharing my screen now.
ठीक है धन दो यही दो अरे ये नहीं वो दो
Sir, is it visible?
Yeah.
Yes.
Please go ahead.
Yeah. So I will be presenting. I welcome you everybody to my research finding presentation for 26th Hooker Award for the biennium 2018-19. So I will be presenting whole of my presentation. My area of research is crop improvement and particularly rice improvement. My significant achievements, I have divided whole of my achievements, our team efforts with a full of team of student, particularly to taking the student and scientist about product development. I will be presenting all the products, then new knowledge, what we have generated, then how much it has given impact to the society, and how many students I have guided. So under this, my talk, these will be included. So while coming to the product development, 45 rice varieties are released, particularly through CVRC 29 and SBRC 16. And I am developer of 31 varieties and associate developer in 14. That means co-authorship in the proposals. So through classical breeding, 41 varieties are developed, through molecular breeding, 4 varieties, and number of states covered 16. Particularly if you will be classifying ecology-wise, lowland will be 17, irrigated 15, aerobic 10, upland 3. So while we will be quantifying what was the impact of these varieties in the society. So these 45 varieties, actually the seed intent is around more than 300 quintals of breeder seed, which is covering, which is giving around estimated 19 lakh quintals of certified seed and covering around 63 lakh hectare area, which is generating a net gain, additional gain of 500 crores per annum with a gross return of about 11,000 crores. And this is only we have calculated taking the seed chain. And there are other things also, seed companies, farmers to farmers, and other approaches also. So these are the 45 varieties. In brief, I can say, so there are all ecology like, classification of NRRI for easy understanding of the farmers. We designate 100 is for upland ecology, 200 for aerobic cultivation or adaptation, 3 variety series is for irrigated ecology. 400 varieties are for shallow lowland. 500 is for waterlogged ecology. 600 series is for dry situation, that is boro and dry season. 700 hybrid. 80 series, 800 are developed through marker assisted and biotechnology. And 900 are those are aromatic varieties. So here these are the for different ecology, and I can say here CR-Dhan 307 I have highlighted, that is a super rice which is named as Maudomani and 135 days duration. It is giving around 10 ton per hectare. Many across many we have seen many in the farmers field. And similarly, these are indica tropical japonica background. Similarly, CR-Dhan 508, it is also in the lowland, is giving like that around more than 8 tons. And the other varieties like CR-Dhan 800, then CR-Dhan 801, 802, these are through molecular breeding approach. So also we have signed memorandum of agreement with 35 companies, and super rice with 9 companies, and so many like these are the agreement now till date. Next, please. Ecology wise, I want to say some of the varieties prominently. Our team contribution is for lowland. So CR-Dhan 500 I started and then continued, and the varieties like CR-Dhan 401 in four states, then these few varieties for Odisha states, then 505 is for Odisha and Assam CBRC, which are more than 2 states are through CBRC. Then CR-Dhan 506 is for Assam, Andhra Pradesh and Karnataka. And these are the photographs I have shown here. And you can see the variety 508 is an indica tropical japonica derived line. You can see the plant type of the variety, and yield is around 10 ton it is going also many places. And there is another variety, CR-Dhan 409. It is shallow lowland, but popularly known as in my name, that is by the farmer, they gave the name after getting the culture, they started giving Pradhan Dhan. So then finally I released in the same name, and that is a very good, what I can say, lowland variety with very premium quality of grain. That is very high yielding, very premium quality. That means value added variety. Many type of preparation can be made from that variety, and good yielder. So farmers very high demand in Odisha, and 8-9 companies they have already signed MOU for this. And fisheries like it is a trade mark type. What is that balami type of grain here we say in the eastern region is very premium quality of rice is generated, and yield is very good, and particularly lowland rice. And you can see another one variety. This is climate smart and is released in the name of Subhas CR-Dhan 802, the legendary freedom fighter from Cuttack, Odisha. And in his name, the parliamentary committee, they recommended that one variety should be in the name of the freedom fighter. The Cuttack is the birthplace. So I named this variety in recognition to the great legendary freedom fighter. And few varieties like other irrigated varieties, these are for many varieties, many are released through CBRC. And the important one I want to show here is the Maudomani variety. It is a super rice variety. Its yield many places it is exceeding 10 ton per hectare, and very compact panicle, high grain number, around 400 grains per panicle, and very strong column. And you can see the phenotype of the plant. And it is through for irrigated ecology, and harvesting time is around 135 days duration. So similarly, so many varieties for this ecology, irrigated ecology. Next, we can see the aerobic varieties. That you know, aerobic is very water saving varieties and very much required for the eastern region of the country. You know, there are limitation of water, so these tolerates mild water stress. So also the grain type of the many of the aerobic varieties are very good. So long slender type, and preferable in like Chhattisgarh, Madhya Pradesh, those area, and many are also for Odisha. So while coming to these are about my products I told you. Then what actually we have generated information that I want to say about these, and our team efforts is mainly is for mapping up complex trait as well as gene pyramiding and gene stacking. And we have published about 122 books, 122 peer-reviewed publication and books, chapter 17, lead lecture I have already delivered 6, and students I will be showing. Then this complex trait, I want to start from abiotic stress, how the complex and what we did there. So first we collected a huge number of germplasm for cold tolerance. I am telling low temperature stress, seedling stress tolerance. So that is a very important trait for burrow rice, you know. So we wanted to use those in the breeding program. So we collected a huge number of particularly chilling stress tolerance type from Assam and Manipur, Mizoram, like that, and we analyzed, and that paper we validated the markers what were published in that, and also validated the donors and published that. Then next what we did, we made a good panel out of that, around good panel. Then we took all the reported genes in that, and then also we saturated the chromosomes with more SSR marker, and we could found some are novel and some QTL already validated, which can be useful in breeding program for the particularly burrow rice in India. And these are around 11 QTLs we found, and if can be pyramided, we can enhance the chilling tolerance in rice. So next what we did, we got a very contrast genotypes here. I means around 21 days it is surviving at 4 degrees Celsius. So we thought, what are the genes here? Maybe we should know, and we took a susceptible as well as this contrast, and we did the RNA-Seq, and we could found many of the novel transcript which were regulating this cold tolerance, and those can be useful for breeding of cold tolerance. Then we started also for high temperature states. Also, we made a global collection of the donors line as well as susceptible lines used for high temperature breeding globally, and we also validated some of the already reported markers, and then we took some and we reported some of the markers associated with these high temperature stress tolerance, which will be useful for the breeding program. Next, about biofortification, you know, this iron and zinc, very important. And then we actually targeted what are the candidate genes, and many small QTLs are available, and those were difficult. We are unable to pyramid, and you know, this iron and zinc is a very challenging work, and we could report through linkage disequilibrium mapping. We could report 4 novel QTLs for controlling these traits for zinc and iron, for particularly for iron content 2 genes and for zinc content 2 genes, in particularly in rice grain. And also then our work was on protein biofortification. And also in case of protein content in rice, we also reported 3 novel QTLs which are controlling this grain protein content and will be useful for biofortification in rice. Next, about the abiotic stress, particularly drought stress, is very very yield limiting one, and we started working on that area also. Then there we actually went through this biparental mapping here, and we got many of the morphophysiological traits involved during reproductive stage in the tolerance control. So we got for many traits for genes, novel genes we got actually which were not reported. Those are like leaf rolling, leaf drying, harvest index. These 3 were reported by us in our team, and similarly also we reported particularly using mapping population for proline content is related to drought as well as relative chlorophyll content and also chlorophyll content. And similarly, in another paper, we reported relative water content is responsible for the drought tolerance, and reliably we can use in the breeding program. So marker and trait location gene are reported for these traits. Similarly, then our work is particularly about biotic stress, that is bacterial blight resistance gene. We analyzed the global scenario, and we saw how many, about 45 genes are reported in bacterial blight, and we thoroughly reviewed the bacterial blight mechanism, then deployment in this, and genetics holistically, and published it. And then our work was 3-gene combination, and we published that work also in Jalmagna. And similarly in the combination also, XA21, XA13, and also XA21, XA5 also, the combination is giving very good resistance. That is also published, that work, and can be useful. Similarly, about biotic and abiotic, actually we put together gene stacking pyramiding in Sonna background, and we put submergence and bacterial blight together, and that work is also published in scientific report. Similarly, also now already in review, this Maudomoni super rice, we have introduced sub-1 and grain yield controlling QTL, that is GW5 in Maudomoni variety. Also, that is under review now, and sub-1 plus Strongcolm plus then wealthy farmer panicule, that is OSSPL14, and 2 genes, particularly bacterial blight combination in Sonna background. Already we have also, this is in a review system. We have already, this work is over and we have submitted. And this another paper relating to which are the markers, what are the donors, what is the adaptation strategy in case of rice, that we validated and published, so that will be useful in marker assisted breeding. Then about, another important thing is phosphorus and deeper rooting. This trace also we targeted, we thoroughly studied that, and that we reviewed that paper and published, and then we also saw where abundance of this POP1 gene in the land races, particularly early duration groups, and that work, where what are the donor lines, where that the marker and gene is working, which line, then that we validated and published in that for breeding purpose. So while coming to this also, we did another one. We took a bigger panel of population. There, what we did, we analyzed what is the root angle in there. We studied the root angle and how it is behaving, and what are the already reported markers, whether we are working or not. Then thoroughly we studied and we reported in rice science, and that is will be useful for this root angle, that is deeper rooting. Shallow rooting is in irrigated rice, and deeper rooting, if we can increase the angle by genetic means, then that will be more deeper will go, and it will derive more of the moisture. So now already we have worked pyramided Drought and POP1 in 4 popular varieties. That is Lolat, in the eastern region, is a very popular variety, but that is adapted to the irrigated ecology. So we want to convert it into rain-fed ecology by orienting its root architecture as well as phosphorus tolerant. Under low phosphorus also it can work. So Lolat is very popular, Nabin is very popular, MTU1010 is popular, and Shatabdi is popular. All these 4 we have already stacked these 2 genes. Now these are ready. Material is in BC2, I think F4 generation. Now we will be submitting this manuscript. Then coming to the low light, our team is also working on low light, and we conducted some transcriptome analysis, and we found a very good, interesting result. And the transcriptome which were for novel, were expressing more, were particularly relating to the photo system, photo capturing enzyme, those pathways, and those were first reported in this. And after light also, we also think for this yield QTLs, that is grain 1, and we could find this haplotype characterization, into our land races it exists, but there is allelic variation exists, and we could prove it by sequencing the amplicon, and there was enough variation in that, and published in genomics. Then we also we also thoroughly went through the global literature about the what is the mechanism of iron toxicity. You know, in Odisha and northeastern part, there is iron toxicity tolerance we need. So we studied the homeostasis, mechanism of uptake and biofortification, and efficiency enhancement of iron and zinc, also biofortification. And we published the latest one, and that is a review type of publication, compiled everything together and published in Environmental and Experimental Botany. And that same thing, we collected a huge panel, we prepared and developed a panel population, and we studied the association mapping for this trait. And now that is recently, within a week, we got acceptance that in +1, and many, means around 3 novel QTLs are reported for iron toxicity tolerance. Then our work on seed, particularly section and seed vigor, seedling vigor, about that also we studied a panel, and we reported markers for marker-assisted selection, which were strongly associated with the trait seedling vigor. Also, we reported that panel. We used a small panel, of course, for initially for physiological biochemical traits related to seed vigor. And particularly, we concentrated here the antioxidant properties of the seed. And we found that gamma oryzanol, total phenolic compounds, total anthocyanin, and carotenoids are associated with these traits with the markers. And as this was the very small population panel, we tried to increase the panel size and also saturated the chromosome with more number of primers and markers. And we did that work, and now we have submitted that to RICE, I think, and that is now under review, and that is the physiological traits particularly related to seed vigor in RICE through association mapping, and now it is under review. And another work, from the same panel, we divided and we did that bigger panel for antioxidant, again related to seed vigor, and that is under manuscript, already is going on preparation. And also these physiological traits earlier, which were, sorry, this is not physiological traits, this is for biochemical traits related to seed vigor. That already we have finished the work, and now we will be submitting that work. And about this dehulling and germination related, some ethylene production also, this work also we took up and published in one important journal. So that is about this creation of our new knowledge to the science. And then about what is the actually, how I could say that this much of we got profit. That is a simple calculation I have showed. This breeder seed intent, only taking the breeder seed intent, how we are calculating, excluding the other things, farmers to farmer, then companies we are not considering. Here estimated coverage, we can know the breeder seed, then how much it is in terms of certified seed, and that certified seed, how much it is covering in the land area. And finally, we are calculating actually 5% advantage over the best variety existing. That is the condition for release, and the national average over which we are calculating, that is 2.5 ton per hectare only. So it is a very, very minimal, we are showing very minimum amount, that is, so in this way calculated. Here I am showing from the breeder seed 375 crores, and this is net. And if you will be telling about the gross calculation, it will be something around 11 to 12,000 crores of rupees. So student guided, my students at the major they have done these work, particularly PhD student 10 and MSc student 12. So what we want now, we are doing for climate smart now, developing variety, particularly putting together submergence, drought tolerance, stagnant flooding, anaerobic germination, moderate seed dormancy, then measure diseases and insect tolerance in a high-yielding popular variety, particularly Swarna variety we are targeting. And we have already stated sub-1 plus drought QTLs and yield QTLs under drought, 3 QTLs and sub-1 plus 3 XA genes plus BPH 3 BPH genes together now already stacked in Swarna. That work is one of my 2 PhD students are now currently engaged in that work, and now it is almost going to be completed, that work up to this, and we are interested, we will be going on adding more and more trait to make it more resilient to the climate. So at the end, I thank by showing my variety. This is the super rice variety, Maudamani. I was showing this is a dream variety, which is giving 10 ton per hectare. And I thank everybody profusely for patient sharing. And also I thank my teacher, my advisors, and my student particularly, who has contributed enormously in this work. And I thank again, once again, the IRA, Honorable Director IRA, and authorities IRA for conferring, for selecting me for this Hooker Awards. Thank you very much. Thank you.
Thank you, Dr. Pradhan. Can you please unshare your screen so that we can have the full view?
Yeah, share. Share it. Stop share.
On the top, you have stop share.
Yes,
Right.
sir. Okay, sir. Thank you.
So, Chairman, sir, over to you for your remarks. Please unmute, sir. Please unmute yourself, sir.
Thanks. Good. हो गया?
Yeah. We can hear you now.
Okay, right. Thank you very much, Dr. Shad Pradhan. Rather, I should congratulate you for giving a wonderful lecture. In a short period of time, you have given a lot of things that you and your team has been doing. I'm very impressed by the work that your team has done, not only in developing different varieties, but different ecologies, but also generating new knowledge and involving the students in your work. I have been my opinion that all the good laboratories should be open to students. And through their work, since it is always a time-bound work, and if it is properly defined, the students' thesis work can be a good piece of research, and you can generate a lot of information in shortest period of time. All the institutions, I must say that, should have this facility to allow the students from working in different institutions to do their PhD and MSc thesis in the institutes. This is a great approach that his team has followed, and through that they are generating so wonderful informations and products like climate smart varieties with multiple traits, QTLs. This is that he has narrated just now, that in Swarna they have put in several QTLs for different kinds of traits related to different kinds of stresses. Dr. Pradhan, the team of Dr. Pradhan has done wonderful work in lowland areas and developed so good varieties. Some of them we have also tested and found them very, very good. His work on biofortification,
Yeah.
Biofortification, like nutrient-dense rice variety, development of rice varieties with zinc and iron, and the traits like, particularly since for some time I was associated with Boro rice development. I also wrote a book on that Boro rice, and I found that the low temperature, particularly during early stage chilling, is a very important and important factor in Boro rice, and they have been able to develop identify resistant genes and develop varieties with these characters, which will go a long way in helping developing Boro rice varieties. I think I don't want to go over what all that he has done, but I find a wide range of activities, right from different kinds of stresses to biofortification. Their work is really, really wonderful, and I can understand, and anybody can easily understand why he has been selected for this award. He deserves that, and with this, I would like to congratulate him very much, and also thank Dr. Ashok Kumar Singh that he gave me also this opportunity to participate in this meeting. Unfortunately, as I told earlier, I couldn't see the message since I was busy with my wife. She was in the hospital. Only yesterday evening she has come from there. So I was totally unaware of this event, but still I really enjoyed. And after listening to Dr. Sarath Kumar, I once again my mind goes towards those scientific developments. Otherwise, I have been totally away from this. Currently, I'm totally working with the application of science to agriculture, rather than thinking of the scientific development. In fact, I'm not quite aware of these things now, and my mind is totally towards the application of science to the farmers. And as Dr. Ashok Singh has rightly said, more of my time I devote now for literature. So almost 100% you can say, except 20% the time that I spend with the farmers, I talk about science. Otherwise, most of the times I am busy in writing, reading, and publishing Hindi literature, stories, poems. Are now a novel is coming soon about that is from Germany's days. I have studied in a communist country, and I've seen how the communism has worked there and how the people have suffered, and that is the kind of experience that have been put in that novel, and that will come in this month only. So I once again thank you very much for giving this opportunity, and I really congratulate Sarath Pawar once again, and wish that he continues working like this, and many others, young scientists, follow him the way he and his team works, because that is the way that you have to have a very scientific approach and defined objectives. Once you know what you want to do, you can really achieve that, and they have very well defined their objectives and working accordingly. Thank you once again. Thanks very much, Dr. Ashok.
Thank you, sir. Thank you so much for wonderful remarks. And congratulations to Dr. Pradhan for incredible achievement for any single person in terms of product, in terms of publication, in terms of capacity building, human resource development, anything that you name. It's really incredible. Congratulations.
Thank you. Thank you, sir. Thank you very much.
Thank you. Thank you, sir. I request our Dean, Dr. Rashmi Agarwal, for formal vote of thanks.
Yeah, thank you, Rauf. And it's my pleasant duty to formally propose a vote of thanks to all dignitaries who joined this particular session. Honorable Dr. R.K. Singh, former Director Research, Acharya Narendra Dev, University of Agriculture and Technology, Kumarganj, Ayodhya, and eminent teacher and literary personality, which we just heard him, who is also the chairperson of this session, Dr. A.K. Singh, Director, IRI, Dr. Sharath Kumar Pradhan, who is a recipient of 26th Hooker Award today, and a chief guest, I must say, the today's function. Distinguished guests, joint directors, project director, heads of the division, professors, faculty, students, ladies and gentlemen. At the outset, I would like to congratulate Dr. S.K. Pradhan for getting this prestigious Hooker Award. And he gave a very systematic and excellent presentation. And this is really a treat for all of us and for all the students who joined this particular session. So they should learn how one can proceed systematically and give the products to the farmers. So hearty congratulations to Dr. S.K. Pradhan for getting this award. I'm so thankful to Dr. R.K. Singh, sir, for sparing your time, and in spite of your such a busy week you had, and your better half was not well, and she was in hospital. So we are so thankful to you, sir. In spite of all these difficult situations, you could make it and join this award presentation today, and gave your valuable remarks which will be helpful to all of us. I'm thankful to the speaker, Dr. Pradhan, and also his contributions in the field of rice breeding, which he highlighted, definitely will find a place in the research panorama of Indian agriculture. And he's very nicely categorized them into the products and the knowledge generation, and all supporting with all the published papers. That was really commendable. So all the thanks to Dr. S.K. Pradhan. I'm thankful to all the distinguished guests who joined and kindly who accepted our invitation. And special thanks to Dr. R.M. Singh. I could see as a distinguished invitee for this particular presentation. I'm thankful to our director, Dr. A.K. Singh, who had been guiding us throughout the convocation program, and today also, sir, for your support and guidance. We are very thankful to you. And thankful to all the joint directors, head of the departments, professors, students who joined in large number. And I must say that they must have been benefited by this award lecture, and all the other invitees who joined this particular session. So I'm once again thankful to all of you. I'm also thankful to Rauf, Dr. R.R. Burman, Dr. A.K. Mishra, and other team members who very meticulously looked into the online mode of presentations, and which went on very smoothly. So with these words, once again, I thank you all of you to join this session. And it really had been a very fruitful session, sir. So with these words, I think we would like to
Thank
wind up
you,
today,
Dr.
sir.
Rasmi. Just for information of Professor R.K. Singh and Professor R.M. Singh, that tomorrow we are going to have at 11:30 Lal Bahadur Shastri Memorial Lecture by Professor Ramesh Chand, member Niti Aayog. So it would be interesting to listen to him. If you find time, kindly join. And
Sure.
also in the evening at 4 o'clock, we have Rao Bahadur B. Vishwanath Award, which has been awarded to Dr. G.P. Singh, Director of Indian Institute of Wheat and Barley Research. That award lecture is in the evening at 4 o'clock today. We have sent all the links to your mail. If you find time, that will be wonderful. Thank you so much.
Thank you.
Yes.
Thank you. Thank you.
Thank you all. This way we